Welcome everyone. Welcome back to the channel. What we are going to cover today in this channel is talking about graphs. And if you have not seen the previous video on graph, which is on graph fundamental, I suggest you to please go through that first. And let's start this class only when you have understood the graph fundamentals. So what we are going to do today is graph problems, and this is the first session of graph problem. So if you are following this channel, or if you are visiting for the first time, then just for your understanding what we cover here, we cover the CAT quant topics, not only CAT, INMAT, SNAP, IFT, all these entrance exam which are based out of India, or quant topics relevant for those exams. So we cover end-to-end quant syllabus, and currently we are covering graph. And for every topic, how we cover is typically a 1+2 model. So we cover the basics or fundamental in the first class of that topic, which for graph is the previous class. We had covered the fundamentals of graph, very important for you to follow up on how we are going to solve the problems. That's the first class of any topic. The second class on the topic is solving problem level 1 or some level 2 problems, just to ensure our fundamental understandings are absolutely clear. You see what are the different type of problem that can come, and how to apply your fundamental or concepts into a problem scenario. So the applicability, the conceptual clarity, everything will get built the first session of a topic, first problem session of a particular topic. And for graph, that is the session that we are going to do today. And in the second session of any topic, or the third session, or in any topic, which is the second problem session of that topic, we typically cover the advanced level problem, which has a higher probability in terms of coming in CAT, XAT, IFT kind of exam. But having said that, there is no way I'm saying that problems that we are going to do in problem session 1 or the fundamental problems class, it does not have any chance in coming in CAT. Actually, we will solve few problems that are previous CAT questions as well. So with that, if that is clear, let's go ahead and start right away. And just one more point before we start is, if you see a problem and then don't continue watching the video, you can possibly pause the video, try it at your end for 2 to 3 minutes, and then if you are able to solve, come back and see the solution, or if there any different approach. If you are unable to solve, I would suggest come back and see the solution, but at least try for 2 minutes from your end, so that the your understanding about the problem or your thinking gets much more refined, rather than continue watching the solution. So that's one piece. The next piece is, let's get started right away. We have already give you a summary brief on what to be expected in the class. So let's see the first problem. It talks about draw the graph mod of x minus 1 plus 2 minus 3 and whole mod. So before we go there, so just a quick recap how we did the modulus. So we saw what is the graph of mod x. The graph of mod x looks like this, right? So what we are essentially trying to say is, if a relation is y equal to x, for that we have a graph like this which goes through center. Now if I put a mod x, now there cannot be anywhere y value can be negative, because mod of x, which is equal to y, mod of x is a distance, representation of a distance, and distance cannot be negative. So mod of x is always going to be positive. So this part, just a minute. So this part will get here, will get up. So for x less than 0, this side x less than 0, we will have y positive. So y cannot be negative and coming down towards this, it will go up in this direction. So that's the graph of y equal to mod x. Now what we also have done is, so this is the graph of y equal to mod x. Now what we have seen is there are two variations, and again, if you have done the previous session, it's understandable for you, but if you are seeing this for the first time, a quick recap. Y equal to mod x plus 1, if this is the graph, so this same graph, what will happen is, now I know y can be 0. Y can be 0 when x, sorry, y cannot be 0 here because mod of x uh, is always greater than 0, because that's always positive. So in this case, when x equal to 0, I will have y equal to 1. So the same graph will be shifted up by a unit. So this is 0, 1, right? So similarly, if I have y equal to mod x minus 1, then this graph will be shifted downwards by a unit. So this is 0, minus 1, right? Similarly, so now we can understand how it is happening, and also the other part that we have done is y equal to mod x plus 1. If this is the case, then we say if it is plus 1, again, this is going to be my base graph, this is going to be my base graph, and this graph will be shifted to the left. Why to the left? Because when x equal to minus 1, I have y equal to 0. So minus 1, 0 will be a point. And similarly, if I have y equal to mod of x minus 1, then the graph will be shifted to the right. Is 1, 0. So these are the four variations. So these are the four variations that we can see coming out of the base graph. A quick recap on what we did. So if it is y equal to mod x, 1 is added outside the mod, it will go up. 1 is, if a constant is subtracted, if 1 is subtracted, it will come down by 1 unit. If within mod 1 is added, it goes to the left. Within mod 1 is subtracted, it goes to the right. Don't try to memorize this, but try to see logically how it is happening. And then from one idea or mental map on that, but don't try to mug up right away. So then let me just delete all this. Okay. Now coming back to this problem. So we first have, let's say, y equal to mod x minus 1. Let's go step by step. Mod x minus 1. So can I say this graph, mod of x minus 1, I know. Mod of x minus 1, that means this to be shifted on the right. This is the graph where it is 1, 0. Basically, in this equation, if I put x equal to 1, y becomes 0. So this is the one. Now let's say if I add 2 to it, now what will happen? This same graph will be shifted 2 unit up, right? So that means this graph will be shifted 2 unit up. So at x equal to 1, we will have 1, 2. So this same graph will be shifted to the top. This is, now if you put a mod, it will be kind of same, because x minus 1 mod plus 2 can never be a negative number, because x minus 1 mod is positive and plus 2 is also positive. So positive plus positive cannot be a negative. So even if you put a mod, it will not change, right? There is no negative value of y possible even without the mod. So even if you put mod, it will not change. Now the interesting fact. Now if you just in a different color. Let's say now if I subtracted 3, So if I subtract 3, what will happen? If plus 2 takes the graph upper, minus 3 will takes the graph down. So basically, if I see from here at x equal to 1, at x equal to 1, at x equal to 1, this part will be 0, this plus will be 2, and this plus will be minus 3. So y will be minus 1. So at x equal to 1, y will be minus 1. So the same graph will start coming down, and we will have this graph where at x equal to 1, y will be minus 1, right? So this is what will happen to the graph, right? Because from here to here, it will come down by 3 unit. So the yellow line will come down by 3 unit. So y from 2, y will come till minus 1. So this point is 1 comma minus 1, like I said, right? So this red one will be your graph. Now think of this. Now think of this. If I put a whole mod out cover, so that's what is given. If I put a whole mod as cover, now see what will happen. Okay. Before that, what we need to see is y will be equal to 0 in certain cases, right? Y will be equal to 0 if I have x equal to 2. If I have x equal to 2, y will be 0. So that part is there. So at x equal to 2, so can I say this is nothing but 2 comma 0, right? So 2, and then if I have x equal, so this is 2 into x. Now if I also have, if you see, to become y equal to 0, I need the value inside plus 3 or minus 3. Now plus 3 is possible when I put y equal to 2. Let's see, when is minus 3 possible inside. Minus 3 possible inside when it is x equal to so minus 3 inside, it's not possible because x minus 1 plus 2 is always a positive number. So we can say at x equal to 2, at x equal to 2, we will have y equal to 0, and at x equal to 0, we will have y equal to 0 comma minus 1 is 1, mod of 1 plus 2 3, y also equal to 0. So this won't cut it here. So let me just redraw this. This will not cut through here. This will basically cut through here. Right? So it will cut through here. So this is a point, right? So now what we need to understand is the whole thing has a mod. Now the whole thing has a mod. That means this part, this part can never be a negative value. So this part will go on top. So basically, what was your graph? Your graph was like this. Let's say it is passing through origin. The graph was like this, where it is 2 comma 0 and 1 comma minus 1, and this is 0 comma 0. Now because of mod, we will this section will be shifted to the top like this. This section will be shifted towards the positive side because the number cannot be a negative number. Mod of x minus 1 plus 2 whole mod minus 3 whole mod, the entire thing is a mod, so it cannot be negative. So it cannot have a negative component. It will be a positive part, right? For example, between 0 to 2, previously we used to have at x equal to 1, we were having y equal to -1. Now at x equal to 1, let's see what will happen in this. At x equal to 1, we will have 0 plus 2 minus 3 whole mod. So this is now 1 mod of -1 or 1. So now here it will be 1 comma 1. So what it was 1 comma -1 before, it will be 1 comma 1, right? So this point will be shifted to this. So basically your final graph will be look like this. Come till here, here, come here, then go up. So this is 2 comma 0, this is 0 comma 0, this is 1 comma 1. This is the final graph. So I hope you understood how we are doing it. We are not munging up absolutely what will happen if there is a modulus inside or plus outside plus inside. We are just trying to logically see what is possible. That's why you see when I was also solving, I was not blindly following what will go up, what will go down. We just have a rough understanding and we are just applying that in the given scenario. So we saw in the last section on x equal to 2, y will be 0, then we actually go ahead and figure out on what other value of x, y can be 0. So then we realize y can be 0 at x equal to 0. So we also kind of doing it and trying to understand it. Okay. So hope this is clear, but absolutely make your concepts clear. You can't mug up things when it comes to graph. You have to be visually and conceptually very clear, right? So I hope this is clear. So if you have doubt, please feel free to drop a note in the comment section and we'll be able to help you from there. Okay. Moving on to the next problem. Let's see what is given. Okay, draw mod of x minus 1, mod of x minus 3. So it is same as saying if x equal to x minus 1 and x minus 3. Now if I can draw this first, let me see. So it is basically a quadratic equation. So how a quadratic equation is drawn, your zeros or roots are 1 and 3. So that means the graph will go like this. Because if I can break this up, it will become x square minus 4x plus 3. So my coefficient with x square is positive, which is 1. So that means the graph will be opening upwards. Recall your quadratic equation class, or if you have not gone through that video, I will put the playlist in the description box. Please go through that. So in a quadratic equation, we first identify what are the zeros or the roots of the equation, basically for which the equation will become 0. That's what 1 and 3. If I put 1 for x or 3 for x, the entire equation becomes 0. So 1 and 3 have become my root. And then we know it's a parabola, or it's a this kind of shape. This is called parabola. So this will be a parabola, but also whether it will be an upward open parabola or a downward open parabola. Sorry, it will be an upward parabola or a downward parabola. That will be decided based on what is the coefficient of x square. So coefficient of x square positive, that means it will be an upward parabola. Coefficient of x square negative, that will be a downward parabola. Again, absolutely covered in great detail in your quadratic class. Now this is 1 comma 0 and this is 3 comma 0, right? Now, so that's what we got. But again, like you see, there is a whole modulus, so modulus of this into this. Now, so then what we have to do it, you know, like the previous problem, this section will not exist and this whole section will be shifted to the top like this. So your graph finally will become like this, this and this. So this is 1 comma 0, 3 comma 0. So between 1 to 3, if I put this equation x minus 1 into x minus 3, where x is 2, you will get 1 into minus 1, or minus 1 as a negative number. But if I put a whole modulus, or modulus of this, both makes sense. Modulus of A into modulus of B is same as modulus of AB. But now if I, so this will become mod 1, mod of minus 1. So mod of minus 1 is, answer is 1. So basically what was earlier minus 1 here, it will be plus 1 here. So your graph will be this negative section of the graph. This negative section of the graph will become the positive section, right? And this will be your final graph. So hope it's clear. It's not complicated. Don't get afraid by seeing modulus the graph. It's very basic thing that we have already known. You just need to apply the modulus logic to make it more relevant, or make it correct. Let's move to the next problem. So it says fx, find the point of intersection fx x square plus 4x plus 3. Okay, let's first solve this. So x square plus 4x plus 3, if I know, it is nothing but x plus 3 into x plus 1. You can break 4x into 3x and x, and you will see this. So again, my roots or zeros are minus 3 and minus 1, right? So first let me draw the graph of fx, and I know the coefficient of x square is my 1, so which is a positive number. So my graph will be like this, where this is minus 1 comma 0 and this is minus 3 comma 0. Okay? My graph will be like this. And what is gx to e to the power x? So I know x equal to 0, gx will be equal to 1. And like we have seen, what is the graph of e to the power x? It is basically okay. Just draw it. Will go like this. Now you may ask why. So basically gx, normal graph where e to the power x is less than 0, it is almost a flat line like this. It is almost a flat line like this. So if it is a flat line, it will cut the quadratic equation or fx in two places. If it is a flat line, and your other equation is going like this, so it will anyway cut it in 2 points. It will cut it in 2 points. Then your then your flat line, then your graph going like this, and your flat line actually become very high. So somewhere, let's see. So somewhere, if it continues going up like this, this line will cut somewhere here. It will cut a little up, but somewhere here it will cut. So that's what I'm trying to say. So at x greater than 0, e to the power x much greater than x squared plus 4x plus 3. At x equal to 0, it is 1, but after 1, it rises exponentially. If it rises exponentially, so let's say for x equal to 10, you have fx as 13 into 11, which is 143, but you have gx, which is e to the power 10. Now, e to the power 10 is actually much greater than 143. So it will have, so basically, we can say for x greater than 0, for some time, for x greater than 0, e to the power x is less than fx for some time, After that, e to the power x is greater than f to the power x, right? Since e to the power x graph is going like this and your graph is going like this, so what I'm trying to say is this, since the rate of increase of e to the power x is very high, rate of increase of e to the power x is very high, it will somewhere cut the quadratic equation of the parabola, because it goes like this, it will cut it here, and somewhere here also it will cut. So there will be a 1 point here, 1 point here, and then there is a 1 point here, right? So there are total 3 distinct points where there will be an intersection. Okay. Let's move on to the next problem. Now, if you see this problem, f of x minus 4 is given. Now, if you recall what we said, there is something called an even function and odd function. What is an even function? Even function is f of x is equal to f of minus x. And what is the, so this is called as even function. And the even function is also symmetrical around axis. You recall we said fx equal to x square. Fx equal to, let's say, fx is equal to x square. What will be the graph? The graph will be like this. Sorry. The graph will be like this. So this is a f of minus x is minus x whole square, which is basically x square. So this is an even function where I can say f x is equal to f of minus x, because x square and minus x whole square is basically same. So this is an even function, and we can see the graph is symmetrical around x-axis. But if we say fx is equal to x, so f of minus x will be of minus x or minus of fx. So this is called as an odd function. Now this is an odd function, and what will be the graph looks like? The graph looks like this. So this is, so you can say these are odd functions are symmetrical around origin or around the center. So you understand, if there is an even function, it will be symmetrical around the axis, be it x-axis or be it y-axis. If it is odd function, then it will be symmetrical around origin. Now, if you have given f of x minus 4 and see the graph you have got, can you tell me whether it is symmetrical around origin or symmetrical around the axis? We can clearly say this is symmetrical around the axis, because origin is outside, it's not around the origin. So the graph is symmetrical around the axis. If you see the bottom dotted line from the center, if you see the bottom dotted line from the center. So basically, let me delete this part. So if you understood this, delete this. So f of x minus 4 graph you have seen, right? So f of x graph, can we say this is going to be like this? F of x graph is going to be like this. Then only from here I can say f of x minus 4 is going to be somewhat like this, where this is going to be 4, 0. So it will be shifted to the right. The same logic will be shifted to the right. Now this graph is basically an symmetrical around the axis. So this is an even function. This is an even function, right? This will be an even function. Now, if this is an even function, f of x minus 4 is basically same as f of minus of x minus 4. Or in this case, we can say f of 4 minus x. So the graph will be symmetrical around x-axis. So the graph will be symmetrical around axis. So f of x minus 4 will be very symmetrical around f of 4 minus x. So the nature of the graph will kind of remain same. The nature of the graph will kind of remain same, but this is x minus 4, this is 4 minus x. Obviously, the values will change. So this graph will be shifted. So for x minus 4, if it is like this, that this is 4 comma 0. For 4 minus x, it will be shifted to the other side, or it will be like this, where this line will be minus 4 comma 0. So your final graph will be not like this, not exactly like this, where this line is minus 4 comma 0. This will be the final graph, right? So instead of x minus 4 this side, 4 minus x will be on the other side, which is symmetrical, right? So this graph, so like I said, fx is symmetrical around the axis. So fx is an even function. So f of x minus 4 is going to be same as f of 4 minus x, because fx is going to be f of minus x. So the graph of fx minus 4 and f of 4 minus x will be symmetrical, same, but it will be shifted to the other side of the axis. Because it's an even function, it will be symmetrical around both the axes, right? Okay. Please, if you have any doubt, feel free to drop a note in the comment section. Now it says find the area between x square plus y square equal to 2. So we know x square plus y square equal to 2 is a circle. And how can you say the circle? It's basically, for circle, we have x square plus y square equal to r square is the formula, where r is the radius. In this case, 0 and 0 at the origin, and r is the radius. So in this case, this will be root 2 comma 0, and this will be minus root 2 comma 0, right? Root 2 comma 0 and minus root 2 comma 0. So because this is nothing but root 2 whole square. So root 2 is your radius. So this is your radius, root 2, right? Now they said x square plus y square actually greater than 2. Greater than 2 means the outside area of the circle. So this area, right? Now, what's the other thing said? The other thing said is mod x plus mod y. Let's say it is equal to 5. What will be the graph? Again, covered in great detail in the previous session. This will be the graph of mod x plus mod y equal to 5. So this is the graph of mod x plus mod y equal to 5. Now, if it is less than equal to 5, that means we're talking about the inside region. We're talking about the inside region of this. This is 5 comma 0, 0 comma, sorry, minus 5 comma 0, 0 comma 5, 0 comma minus 5, 0 comma 5. So this will be the graph of mod of x plus y less than equal to 5. How we get this? Please visit to the previous class where we talk about in depth on how mod x plus mod y equal to 1 can be drawn, and then the same way mod x plus mod y equal to k. Now k can be 1 or 5, but this will be the base graph. Now if it is less than equal to 5, we are talking about the inside region of that graph, right? Now, if we are talking about the inside region of that graph and the outside region of a circle, that means we are focused on the area here. outside the circle, but inside this rhombus, right? So what is, so outside mod x plus mod y equal less than equal to 5 is a rhombus. So this is going to be a rhombus. So this part is going to be a rhombus. If this is a rhombus, what will be the whole area? The rhombus is basically half into product of its diagonal. Now its diagonals are 10. So this much is 5. This much will be another 5. So the diagonals are 10. So half into 10 into 10. Okay. Minus. So that basically covers the entire area within the rhombus, but we have to subtract the area of the circle because we are focused on the area outside the circle and inside the rhombus. So circle area is pi r square, which is pi into root 2 whole square. That means we will get from here is 50 minus 2 pi. 50 minus 2 pi is your answer, the area inside. Okay, well, this is clear. Let's move to the next problem. Let's find the area of the figure bounded by mod of x minus a. So here also, see what we know, mod x plus mod y equal to 5. Mod x plus mod y equal to 5. So we knew this is the graph of mod x plus mod y equal to 5, right? Where this is 5, 0, 0, minus 5, 0, 5, minus 5, 0. This is the base graph of mod x plus mod y equal to 5. Now, if it is mod of x minus a plus mod of y minus b, so in this case, we know this is nothing but mod of x minus 0, mod of y minus 0 equal to 5, right? So we can say the center on the this point, diagonals intersect at 0, 0. So the given one, mod of x minus a plus mod of y minus b equal to 5. In this case, your diagonal will intersect at a, b. But think of this. What is they are asking? The figure of the area. The area figure of the area is half into product of diagonals. Product of diagonals will so basically, can I write half into d1 into d2? These are the two diagonals. Now the diagonal's length will not change if your center changes, right? If I have mod of x minus 0 plus mod of y minus 0 equal to 5, the diagonal length for that equation and diagonal length for if I 0 instead of 0, if I write a plus mod of y minus b equal to 5, your length of the diagonal will not change. What I'm trying to say is, instead of this, you may have something like this. But this length will be same because this is depends on the what value is there on the right side, not what is inside the mod. Inside the mod just determine the center. The center from here may be shifted to here because of 0, 0 instead of 0, 0. Now we have a, b, right? And that center might shift, but the size of the rhombus or the size of the diagonals will not change. So here also you will need to do half into 5, sorry, not 5. Diagonal lengths are 10, half into 10 into 10, or 50. Your answer. So it's not depend on the, so mod of x, area bounded within mod x plus mod y equal to 5 will be same as the area bounded between mod of x minus a plus mod of y minus b equal to 5, because it just changed the center, but it does not change the shape of the rhombus, the size of the rhombus. That means it will not change the size of the diagonals. When diagonals not change, your area will not change. Let's go to the last problem for today. Okay. Talks about f(x) equal to box x mod x by x for x not equal to 0, obviously, because if x equal to 0, it will become infinite because you have a thing in the bottom. So can I say for x greater than 0, f of x, mod of x will be x only, and below also it will be x, so this will be 1. Think of x equal to 3, mod of x also 3, denominator is also x equal to 3, so it will get cancelled. For x less than 0, mod of x will be x, but x will become minus x. So let's say for x equal, so in that case, your fx will become minus 1. Think of x equal to minus 3. Your mod of x will be 3, but your x will be minus 3. So 3 by 3 will give you minus 1. So for x greater than 0, x greater than 0, it will be 1. For x less than 0, it will be minus 1. So how my graph will look like? Simple. My graph will look like for x greater than 0, it will be like this. For x less than 0, like this. It will not touch 0 because x cannot be 0. So this will be 0, comma 1. And this will be 0, comma minus 1. Right? Don't see the distance because this may look more than this, but both will be 1 unit up or 1 unit down from the origin. Okay, so hope this is clear. So for 3, whatever value you put, it will be either plus 1 or it will be either minus 1. So fx will be either plus 1 or fx will be either minus 1. I hope things are clear. You understood the problem and how we are approaching this problem. If you have any doubt, please feel free to drop a comment in the description on the comment section. I will be able to answer that. And if you need more focus session with me, I will drop my mail ID. We can arrange for that as well. But however, hope this session has added value to you. You understood the foundational problems of graph. And in the next session, we will talk about the advanced level problems on graph, which will be a little complex, little tricky. So it's very important for you to go through this. So if you have solved 8 problems, you have to solve 3x at home before we cover the next session, which is around 20 to 25 problems minimum on the level 1, level 2 of graph you need to solve. And then once we go to the complex problem session in the next class on graph, you will be able to catch up very well. And with that, if you like the video, please like, share, subscribe. That's the main motivation for making this video and making this entire quant section of MBA entrance exam or any aptitude entrance exams available fully for free to you guys. So please at least like, share, subscribe, and that will keep motivating me. Thank you. Have a good day or good night on wherever you are seeing. Bye. See you next time.